Hello grade 12s. Today I am working through a past paper. I've been looking at the Loci aspect, and in particular I'm looking at the cam drawing. Now what we'll remember that from the analysis we've done is that in 2021 they brought back the two aspects of Loci, the mechanism and the cam, and in 2022 they've done the same thing. So again, combined, that's a mark of 40. That the time allocation is also 40. So I'm going to go through this cam and I'm trying to complete it in the 25 minutes that I've got, because they have only got 25 marks they can allocate you. Things like the label, the title, the scale, the divisions, the hatching, the direction, the follower, they've all been done for you. So they're going to allocate marks elsewhere for you to complete. On this one, quite interestingly, they've given us the roller. The roller implies that it is 0 where it is, and the projection from the displacement graph is to the center of that roller. So each time we plot a point, we then have to draw a semicircle or the circle to indicate the follower and draw that. Remember, if you don't, you're going to be about 6 millimeters in this case out, and that's quite a lot in your cam profile, and you'll be losing a lot of marks. So remember that aspect to draw the roller. So they've asked you here, draw and complete the graph of displacement. So let's do that. From 0 to 60, the follower falls 10, which they've given us. Then they say from 60 to 240, the follower falls 48 with uniform acceleration and retardation. So let's just check where that is going now. So we're at 60. Remember, if we've labeled these, it's going to 240, which is over here. So 0, 1, 2, 3, 4, 5, and that would give us 6 divisions. That's great, and that means we can have 6 vertical divisions. So what we want to do is find our middle line, which is 3. Now please remember, if you have got no idea what's going on, which is a bit disappointing if you haven't done some studying for this, you can find the start point because you know where that point is. It's been given. The middle on line 3 we know where it would be, because if we draw a line from the corner to the corner, that line where it hits here is the middle and gives you point 3. This is point 0, this is point 6. So you would find 3 points irrespective of whether you know what to do for uniform acceleration and retardation. Okay, so please, you can get 3 points. Don't just scratch it off and say, I don't know what's going on, and throw away marks. You can find the start, you can find the middle, and you can find the end. So we need to find the extra divisions here. So what I'm doing is I'm going to measure this height here, and they've given us a height here, and that looks like it's at 48. That's fantastic news, because that is divisible by 6. It gives us a measurement of 8 millimeters. So what I can do is mark off a height of 8. So this was height level 0. There's 1. Our next 8 millimeters. There's 2. There we've got 3. 4, 5, and 6. That was great. Now, remember, there's our corner we project to our height level at 1. Where it intersects our vertical 1, that gives us point 1. There's point 2, we project to point 2. Where it intersects with the vertical line 2, that intersection gives us 0.2. 0.3 we've already found. 0.4 is now on the retardation side. We project across where it intersects our vertical line 4, gives us 0.4. We project to height level 5, where it intersects with that line 5, gives us 0.5. Let's do our check for accuracy. These middle 3 lines should line up. Okay, so I'm happy with that. And let's get them to curve around and into the corner. Okay, there's our uniform acceleration and retardation done. Very kind of them to give us an equal height division that we could just measure. Okay, from 240 to 360, the follower rises back to our original position, so it's back to the top here. So simple harmonic motion, the S for simple and S for circle is what I'm going to do. And what I want to then do is, if this height is 58, I want to obviously measure 29 and hope that is the center for me to draw a semicircle here, the construction just on the outside of my shape. Here's my semicircle. Do our divisions. Now we're starting at the bottom, so I would label that at 0. Okay, now I've done this wrong because we've actually only got 4 vertical divisions. So please excuse that. What I'm going to do is put in a 45 and a 45. So that's still 0. 1 becomes the 45, 2 becomes the horizontal, 3 the 45, and 4 is the top line here. I've been so used to doing 6, apologies for that. So if we label this vertical line, that was 0. So 0 lines up to 0, gives me that point. This will be vertical 1. And I've got to line that up with where my 45 is. Where they intersect gives me 0.1. This is line 2 now. Where's line 2 here at the horizontal? Project that across. Where it intersects gives me 0.2. Here's 0.3. Project that to line 3, 0.4 and 4. Again, these middle lines should line up with a straight line if your construction is accurate. And then let's hockey stick into the corner. Okay, so there is my displacement graph completed. Simple harmonic motion. Because they only gave us 4 divisions, we could divide our circle into 4 equal parts. So that's why I used the 45-degree angle. So I've got 1, 2, 3, 4 corners. Okay, now we need to remember we're going to project these across always to our vertical center line. And we need to put in our labels for the angles. Now my direction of rotation is clockwise, So what I need to do is work anti-clockwise with my labeling, because what is happening is it's the cam profile that's turning, not the follower. So because it's the cam that's turning, we label in the opposite direction. For a change, there are no half divisions, which is quite nice. We just need to project these across now. So 0 has already been taken across because we've got point 0 there. So here is point 30. Show the projection. That is the actual point 30 over there. Okay, now save some time. Just project and line it up. Okay, so line it up, make the mark. Line it, oops, 150. And 360 we've got at the top there. And now I want to use my compass to transfer these around. Now this is what makes it quite nice, is when you've labeled this, you know where to take the measurements. So there's 240, I can just mark that off at 240. 210. 270. 180. 150. And we're just marking these all the way around. 300, I can maybe put an arc in there. So 300, 120, 90, 330. There's 60. And 30 is that actual point there. My next step is to get my distance for my roller and go and draw that at each of the points. It was 330, 300, 'and do that for each of the remaining points. Okay, there I've marked off all my points, and now I want to project those. I'm going to project them, join them up with a tangent. So get a nice curve. If you've got a flexi curve, French curves, get a nice curve going. Remembering that it can touch at a tangent, it doesn't have to touch at the exact point where it touches the division. That's got a little bit light here. And there I've got my cam for this 2022 paper. I started this drawing at 3:15. It's now 3:30. So it's taken me 15 minutes to complete that drawing, which means that I have 10 minutes saved, and I can use that in another drawing.